In this video, we're going to talk about periodic functions. So our first example is that we want to determine whether each of these functions shown below is periodic, and for each periodic function we want to find the period. But first, let's talk about what it means for a function to be periodic and what the period of a periodic function is. So let's write down the definition of a periodic function. A periodic function repeats itself at constant intervals. And now, what is the period of a periodic function? Well, let's give another definition. The period is the smallest interval length at which a periodic function repeats. So let's go through each of these functions and tell whether it's periodic. Okay, so this function first looks like a bunch of slanty lines that are just repeated over and over. So is it periodic? Well, the lines repeat every unit. So yeah, it is periodic. And what is the period? Well, the period is the smallest interval length at which the periodic function repeats. This repeats at a length of 1, and that's the smallest interval length that we can go. That's the distance to the next slanty line. So the period then is equal to 1 because that's the distance between the slanty lines. Okay, on to the next function. Is this function periodic? Well, does it repeat itself at constant intervals? No, it doesn't look like it. It's going down, up, then a big down, then it's flat. So it doesn't look like much is being repeated here. So nope, not periodic. Okay, so how about this next function? Is this periodic? Well, does it repeat itself? Let's see, it's going up here, then it's going up in a little bit of a swoop, then another swoop, and it looks like the beginning of another swoop. So yeah, it looks like it's repeating itself, just swoops and swoops and swoops. These two are cut off, but if we were to extend the graph, they would look like these two swoops in the middle. So therefore, it is periodic. And now what is the period? Well, what's the smallest interval length at which the function repeats itself? That's just the distance between the swoops, and the distance between the swoops is 1, 2, 3 units. So period equals 3. Alright, last one. This is a little bit of a jagged oscillation here. Is it periodic? Does it repeat itself? Well, it's a little bit of a jagged up, then a jagged down, then a jagged up, then a jagged down. So yeah, it does repeat itself. This is periodic. And what is the period at which it repeats itself? Well, one option would be to go from the middle of the first jagged up over here to the middle of the next jagged up over here. So that'd be all the way from here onward to there, and let's count how many units that is. So that is 1, 2, 3, 4 units. So that's 4 there. Or we could do the same thing with the jagged downs. We could go from the middle of the jagged down to the next middle of the jagged down. We should get the same result. Let's do it just to make absolutely sure. Go from middle to middle. Now let's count. There's 1, 2, 3, 4. So there we go. We can be sure that the period is 4. Alright, next example. So the graph of a function y equals f of x with period 3 is shown below. What is the graph of y equals f of x on the interval from x ranging from -6 to 6? Alright, so we've got a little piece of a periodic function and we want to draw the whole thing. We're told that this periodic function has period 3, and hey, that's the length of the piece. That goes from -3 to 0. That's 3 units. Okay, so this piece then is the thing that has to repeat over and over and over. So we'll just have to duplicate this piece several times to fill in the interval from -6 to 6. Okay, so why don't we draw it again to the right? So this piece has to go exactly the same way. Has to go, let's see, it goes over 2 units, then up 2 units. So starting here, we should go over 2 units, then up 2 units, and then let's just go ahead and draw that line there, or line segment rather. Okay, so we've got that, and then what does it do? It goes back down the 2 units and then over a single unit. So back down the 2 units over a single unit. So that's our next point. Okay, so now we've got 2 copies of that little piece, and we can see how the function is periodic, definitely. So now let's draw another one. So over 2, up 2 to here. We'll make that a segment, and then down 2 over 1 to here, and then we'll make that segment. Now we're almost there, but we also have to continue it backwards as well. So let's think. Let's think about going backwards. So going backwards, if we're starting at the origin here, then we would go over 1 to the left, then up 2. So let's do the same thing at the end of this this pattern here. Go over 1 to the left, then up 2. You get to here. All right, and then that goes like that. And then after that point, then we go down 2 over 2. So same thing here, down 2 over 2, get to there, and fill that in. Great, so now we've got it. There's our graph of y equals f of x. All right, last example. The graph of a function f is shown below. Given that the graph has period 4, what is the value of f of 6? Okay, so that seems like it's pretty similar to the previous problem. We have a little piece of a function, and let's see, does this length here match up with the period? Period is 4, the length is 1, 2, 3, 4. Yeah, so this is exactly 1 period of the function. So we'll just need to think about repeating this. That would give us the graph of the full function, and then once we have the full function, we can figure out what f of 6 is. Okay, so we need to repeat this all the way up to the x value of 6. So we need to repeat this pattern until we reach 6 here. So let's go ahead and do that. Okay, so we got to start the pattern over. And how do we start it over? Well, we go down 3 and over 1. So next point should be down 3 over 1. Let's go ahead and draw that in. Get our straight edge, put a little segment there. Okay, and now after that, we go right 1 and then all the way up to 2. All right, so we go right 1 and then all the way up to 2 on the y coordinate. All right, so that is our next one. Let's draw that in. All right, and then after that, we go down to -1 and over 1. So down to -1 and over 1. So here we are. Go ahead and draw that. And then keep going. Again, we're duplicating this whole piece. So let's go ahead and starting here, we go over 1, up 1. So over 1, up 1. So now we're at 5. And then the whole duplication process starts again. So now we're back at the beginning because we've got 2 pieces. That's the first piece. That's the second piece, back at the beginning. And how do we deal with the beginning? Well, we just go down to the y coordinate of -3 and then over 1 in the x. So down to the y coordinate of -3 and then over 1 in the x. Okay, so here we are. And we can actually stop here because we want to find the value of f of 6, and 6 is right there in our graph. So that's just going to be this point here. So what is the value of f of 6? Well, the value of f of 6 is the y coordinate, which is 3. So f of 6 equals -3. Now, looking back, there was an easier way we could have done this without having to sketch the graph until we get to the x-coordinate of 6. And that involves using the fact that the period is 4. Remember, the period is the interval at which the function repeats itself. So the function takes the same value at 6 that it does at 4 units behind, that it does at 2. And it has to take the same value at 2 that it does at 4 units behind that, which is at -2. And indeed it is. That point corresponds to a y value of -3, and it's the same as we got when we drew out the graph. Alright, so we really could have done this using no graph at all, just the fact that the period is 4, because we could say that f of 6 is the same as f of 6 minus 4, which is f of 2, and then f of 2 is the same as f of 2 minus 4, which is f of negative 2. And then we're told f of negative 2, that's just negative 3. So therefore, f of 6 equals negative 3. Now we know how to determine if a function is periodic, and if it is, then we also know how to determine its period. In the future, we'll continue learning about properties of functions, such as the behavior of a function at a point.